So it says the advanced placement exam was first administered in 1997. More than 7,600 students scored these scores. Distance learning class took the AP, of students who took the AP Stat class got this distribution of scores and were asked to perform a goodness of fit test along with hypotheses, expected percents, expected values, observed values, chi-squared component, chi-squared statistic, a picture, p-value, state the conclusion, the whole works. The whole works. So let's start out with the hypotheses. Well, the null hypothesis is the distribution of distance learning scores is just like the nation, no change or no difference. HA, same idea, is different than the nation. That's what we're looking at. So there's the null and alternative hypotheses. When we get done, we'll go through and assign points to each thing. So now what I want to do is make a table, and my observed values, the scores are 5, 4, 3, 2, 1. And so my observed values are these here, 7, 13, 7, 6, 2. 7, 13, 7, 6, 2. My expected percents are these numbers right here. 15.3%, 22%, 24.8%. And what I'm going to do now is type these numbers into my calculator. So I'll pause the video and get them typed in. So I have these numbers typed in here, and then what I need to do in L3 is to get my expected counts. Now I know that I can add up L1 and discover that there are 35 students who took the class by distance learning. So I want to take those 35 students and multiply them by these percents. So I go here, and this is going to be 35 times L2. Now these numbers should be reasonably close to these numbers, and you can see they are, and I have a decimal, and that's okay. So I'm going to scroll down a little bit over here, and this is what's going to go right here. So there are my observed, expected. Now these numbers here are the expected counts, how many I thought I would get for each score. Now what I want to do is take the formula observed minus expected squared divided by expected. So in my next column, L4, let me clear that out. It's going to be observed minus expected squared divided by expected. And I get this right here with these numbers. So I could even drag that over here and kind of line that up. And there's what I get. And then when I add up these values in L4, I get the chi-squared test statistic of 7.569. So the chi-squared test statistic is 7.5697, or 976, I suppose. The degrees of freedom for this problem are going to be 4, number of categories minus 1. And I can draw my graph. It's a right skewed graph. It's the chi-squared distribution with 4 degrees of freedom. Here's my p-value, and my test statistic goes right here. Now at this point you can either use your chart or your calculator, and I'm going to go ahead and do a stat test. This is the goodness of fit test. The observed values are in L1. My expected values are actually in L3 with 4 degrees of freedom. Calculate, chicka chicka whir whir. Here is my p-value. My p-value is right there. And so now I need to make a conclusion. And so I can go back and look at this problem to see if I had an alpha level. And since I don't see an alpha level, I can say, since my p-value is bigger than alpha equals 0.05, I will fail to reject HO in favor of HA. I continue to believe the distance learners scored like the rest of the nation. Now, I didn't do conditions, so we should also address the conditions, and probably should have addressed those up higher in the problem. So I'll put a little box here and we'll do conditions and then say, let's scoot those conditions up higher. Conditions. So what do we need? I need this to be a random sample of distance learners. I need a random sample of distance learners. In other words, if we just put all of our best and brightest on the distance learning, I would kind of expect that to affect their scores. Secondly, I could have more than 35 times 10 distance learners. And finally, I need to check my expected counts. So when I go back right here and I look at these expected counts, I see that all of them are bigger than 5. This is great. The smallest one, in fact, is 5.355. So I can say all expected counts are greater than 5. Smallest is 5.355. So the large counts rule or condition is met. So those are the conditions that we have. So that's how you'd work this chi-squared goodness of fit test. Now let's go back and assess points for everything. So I'm going to have the HO and HA be worth 3 points, and we'll basically set it up off of what they were told to do. They said make a chart that shows the expected percents. That's a point. The expected values for each, that'll be worth 2 points because you have to do a little bit of work there. The chi-squared components, that'll be worth 2 points. The chi-squared test statistic, which will be worth 2 points. The picture, which is worth a point. The p-value, which is worth a point. And state a conclusion, which is worth 3 points. One of those points will be the, two of those points will be the correct decision, failing to reject, and one of them will be putting it back into context. They should also put the degrees of freedom, although I won't assess a point for it on this right here. And then we're going to give them plus 1, 2, 3 if they have each of those 3 conditions. In order to get the expected counts condition and the 10% rule condition, they actually have to address the numbers themselves if they want to get that bonus point. So let's count up how many points that is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Looks like 15 points with plus 3. So at the top, you're going to write minus whatever, minus 0. They'd make a 15 out of 15, or up to an 18 out of 15. So that's how we'll grade this quiz.